Permanent magnets, like these neodymium magnets here, are inherently useful things. They can be used to identify certain minerals, like this magnetite here. As you can see, it is quite strongly attracted to the magnet. They can also be used to roughly determine the composition of certain objects. For instance, these scissors may say titanium on them. Are they made of pure titanium? No. No, they are not. Titanium is non-magnetic, and because the magnets stick strongly to these, if they contain titanium, it is not the majority of the metal. A magnet could also be used to mechanically separate magnetic materials from non-magnetic materials. Say you were panning for gold, you isolated your heavies, and you wanted to remove the magnetic iron from the heavies. You could do so with a magnet, and thus purify your gold more. And so, given their usefulness, it might sound like a good idea to go out and buy one of these magnets. However, why buy one of these magnets when I guarantee you have two of these magnets just lying around collecting dust in the form of these, a pair of headphones. Now, if the design doesn't instantly give it away, these are old headphones of the Apple design before they got rid of the headphone jack, and, well, they don't work anymore. Just because they don't work anymore doesn't mean I can't use them in other ways, and it certainly doesn't mean I should throw them away. In this video, I will demonstrate how to properly remove the permanent magnets from this pair of headphones. But before we disassemble these, I have to go through a quick safety and equipment briefing. I will try to keep this briefing, well, brief, but know that it is absolutely essential. In the case of equipment, we're going to need a set of pliers. We're also going to need a set of snips, and we're going to need a knife. Now, in my case, this all comes in one. Granted, I would much prefer to have all these tools in their separate configurations. However, the multi-tool solves one big problem that I have. These tools will get destroyed, and you can only use them for one thing, and the one thing only, and that is disassembling e-waste. This is for safety reasons I will get to in a bit, but know that you should never use any tool that you use for e-waste. For anything else, I also like to use a set of scissors, like this. These are useful for when you're cutting anything like wires that do not cut easily with these snips. There are a gap on these snips that make wires not cut. Now for the safety briefing. E-waste can contain traces of cadmium, mercury, and lead. Granted, the dosage you would like to get from a single set of headphones would be insignificant if you were only disassembling one set of headphones for the two neodymium magnets in the head. However, I'm doing much more than that, and since that sort of exposure can add up quickly, I use gloves whenever I'm disassembling e-waste. These gloves don't necessarily have to be chemical resistant. They could be garden gloves. All that matters is that your skin is not in direct contact with anything you will be touching. Direct contact should be avoided because these heavy metals could absorb through your skin or accidentally be ingested while you're eating if you haven't washed them off properly. Regardless of whether or not you use gloves, you should wash your hands in cold, soapy water afterwards to remove anything that may be on your hands. In addition to salvaging the neodymium magnets from these headphones, there are also certain other byproducts that are also valuable. While copper wire is inherently valuable, this copper wire is braided with other materials, and therefore difficult to mechanically separate. Because of this difficulty of mechanical separation, one might think it a valid idea to burn away everything else that isn't copper. Never do this. I don't care if other people do it. Never do it. Not only will burning release all of the cadmium, mercury, and lead into the air to breathe. So forget the gloves. That'll aerosolize the heavy metals, and you will be exposed much more. In addition, the burning of plastics such as this is likely to create dioxins, which are a horrible contaminant and pollutant. And if you don't think you're breathing it when you're burning it personally, you're lying to yourself. In all seriousness, disassembling a single pair of headphones like this really isn't all that dangerous. In fact, even if I were to lick things in here, I probably wouldn't have too horrible of a heavy metal exposure. Simply because, well, there's only trace amounts in it, and there's not much here. But that said, you really should understand what you're working with whenever you're working with e-waste. And that means understanding the environmental implications of certain things like burning it and the potential hazards it could have to your health if you don't take precautions. Well, now that that ominous safety briefing is out of the way, let's get to work. All right, gloves are on. As you can see, they have a couple holes in them. This is why I don't use them for chemistry anymore, but they're perfect for this because I'm really only concerned of the fingertips maybe touching. Maybe I have a little bit on my palm, but since the dosage is so small, any reduction is really helpful. So, first things first, I'm going to grab a set of pliers. You can see on top, if you actually look here, there's a little line. That's where the plastic separates. Now, I'm going to take advantage of that natural weakness. Now, if I was just doing this for myself, I would take this center portion here. I'm looking through the camera, not at what I'm doing, so keep in mind this might be a little sloppy, but I'd basically take it right in here and I'd crush it. These pair of pliers is perfect for that because it has these jaws here. But I'm not going to do that because I'm not going to assume that you guys all have a set of pliers with these jaws here. So I'm going to do it with the flat portion. And hopefully it will work. What you're basically doing is just splitting these two pieces of plastic apart. There's really no need for any fine work. There we go. Worked like a charm. In this case, I'll be using the knife. And I'm actually not looking through the camera now. I'm looking through somewhere else because I don't want to be looking through the camera while working with a knife. Well, my hand is right here. It's a bad idea. All right, it's off. What I'm going to do now, as you can see, that's the magnetic part, is remove these two wires here and isolate these two components. There we go. So here's the separated piece up close. Now the next order of business is to remove this. And in my opinion, the easiest way to do that is just crack the plastic even more. Apple products, in my opinion, are a little easier to scrap simply because the plastic they use deforms and breaks more easily. Sorry you guys can't see this, but basically, I mean, you guys can understand what I'm doing. Just trying to manually rough up the plastic to remove this center portion right here. Well, the glove wasn't liking the amount of force I was putting on it. The thumb portion was about ready to come off, so I just duct taped it. Should serve the same purpose. I'm just trying to prevent any trace metals from actually getting onto my bare skin. But enough about safety. Now it's time to remove a couple of things. There is a little ring here. I'm just going to dislodge it as best I can. That took longer than I expected. And it actually came off with the other piece of copper. And the outer ring, from what I understand, is actually brass, followed by plastic, followed by a ring of bare copper, and then I have no idea what that piece in the middle is. I'm not sure if it's metallic or plastic, but I certainly don't make use of it. Now, the outer brass ring can be mixed in with the copper waste from the wires, but that bare copper bit right there, that inner ring, is actually usable for just melting. That's pure enough that you can just melt it. I would give it a wash with hydrochloric acid first, but that is melt ready. All right, next order of business is removing the magnet from this external plastic. Now I'm going to do this quite similar to the way I've been doing the rest of it. I'm just going to break the plastic off all around. See if I can't grab it here and sort of tear it. Eventually it will come off. Sorry if my gloves are blocking a bit, but okay. There we go. There's the magnet. Identical to the ones I showed in the beginning of the video. Now all it's left to do is to repeat it with the other side and maybe make use of the rest of the scrap. Well, another inconvenience of having them all in one tool, I cracked this open, but to switch to the knife I have to completely invert it and then pull the knife out. And to switch to the pliers, I have to push this down and then invert it again. It's just a hassle. I'd prefer to have separate tools. But as I said, this solves a problem. So now the process is done for both magnets. Now, all that's left to do is clean up the rest of the waste and see what I can salvage from it. On order of importance is to remove this bare copper from the plastic. This can go straight in a melt so long as there is no plastic on it. I think that's pretty good. And I'll go and do it for the other side. Next, I'm going to remove brass from the plastic as much as I can. A little bit of plastic is no big deal, simply because this is going to get put into a leaching bin anyway. Oop, grab my glove. I need to get smaller gloves. These fingertips are making everything more difficult. Next is to deal with this copper wire. Now, because this has to go into a leaching bin anyway, I don't really bother stripping it from the plastic insulation. It's gonna leach anyway, whether I take it out or not, and taking it out is just extra hassle. What I will do, however, is remove this bottom part here, the connector. Now, this connector is actually brass coated with nickel, and it is slightly magnetic. Not much, not enough to support the weight of the magnets. In this form, it's not that useful, so I'm just going to lop it off right here. And next order of business is this volume controller. Now, this is where the snips come in handy, because I can just break this quite easily and remove this piece. Now you can see into what is essentially a switch. What I'm mostly concerned about is the copper. And in all honesty, while this is cool to look at, I'm just going to snip off the copper right here. Just basically trying to remove any metals that aren't copper to make the copper easier to refine. So there's the copper right there. And I'll just nip this off right here. And all of this should be little wires encased in plastic, but this should all be copper. The metal should at least be copper. So what I'm now going to do to this is just cut it up with the scissors. Careful not to get my glove in there. That would be the death of a glove. Fortunately, I need to sharpen these scissors. I think that's enough. I just need to rough up the surface, remove the plastic in enough places so that the copper wire is exposed. Maybe break that right there. Yeah, perfect. And now I'll just put these brass right here. So this is how I break it down. I have these two magnets right here stuck together. They tend to stick together. They're magnets. I have the bare copper right here. This can just be melted. I have the scrap copper right here and the little brass rings. Those can be thrown in a leaching bin to extract the copper. And then I have my scraps. Now these scraps really can't be thrown away. They contain bits of steel, stainless steel, obviously plastic. They have some copper, some nickel, some soldering, so lead and tin, and all in all, they might contain the trace metals I talked about earlier. So, throwing them in the trash bin is probably not a good idea. What I do is I basically pile them up, and maybe in a later date I'll go through all of them, acid wash them, make sure that all the metals are removed, and then throw them out. Or maybe send them to a proper incinerator. It might be important to note, probably before you get to this stage, that you should really check to make sure that the item in question is really not working before you do this. So these I'll just sweep away into a little plastic cup just for storage. See? These I'll put to the side, bring them upstairs to my bare copper pile. These I will add to the other magnets from the beginning of the video. And these will go in this solution here. This is acetic acid with some copper acetate to help increase the corrosion of the bare copper, which reacts with oxygen dissolved into the solution from the air to form copper oxide, which then forms copper acetate, which is that blue color around the ring. Now this is just going to get added in and tamped down. I definitely need to get a bigger container for this. And now, afterwards, as I said, soap. Come on. There we go. And cold water. Now I'm going to wash my hands one by one because, newsflash, the camera's in my other hand. But you do want to wash them with the soap and the water fairly well, just to make sure nothing is on your hands. And I think it's cold water because your pores sort of open in warm water, which could be a problem. Someone check that. I know it's definitely cold water for chemicals, but I don't know if that's the reason. Well, I hope you all enjoyed. See ya.